Hello everyone, it's a pleasure meeting you all in my mathematics class. I continue with problems in convergence and divergence. This is the problem that I have chosen today. The series is given here. You see that in all my problems of convergence and divergence, I was repeatedly telling that it is for you to find the nth term or a general term, then finding the next n plus 1th term. If you can find that, then applying the test is not difficult. It's simple only. So discussion, or that is finding or testing a series whether it is convergent or divergent, the main thing that has to be known is that you have to get the nth term or the general term. If that is done, almost you are done. I must say that almost you are done with the problem and you will get it. Okay. Now, with this small note, I will start doing the problem. See, you see that here again I am going to use what is called D'Alembert's ratio test. See, what is the D'Alembert's ratio test? It says that you find an divided by an and take limit n tending to infinity, and if this is equal to L and L less than 1 implies the series is convergent. Greater than 1 implies the series is divergent. L is equal to 1 implies the test fails. So these are the things that you must know, that we use that is why I told you find the nth term and the n plus 1th term, and find the ratio. That is why it's called a ratio test. And you find a finite value L. If that value is less than 1, it is convergent. If it is not, that is L greater than 1, it is divergent. If it is equal to 1, the test fails. We may have to apply some other test to find out whether the series is convergent or divergent for L is equal to 1. So that is what we are going to do. Okay. Now, let us find out what is our n here. See, n goes on like this. See, an. See, n is, see, 3, 6, 9. See, it goes on like this. 3, 6, 9, 12. Like that it goes on. And here you may say, you may find that if it is a second term, your x power is 1. If it is a third term, your x power is 2. If it is a fourth term, your x power is 3. So I am going to take the nth term, so it will be x to the power of n minus 1. And you see that this is 3, 6, 9, and if it is, see, it is, see here 2 means 3, 6. If it is 3 means 3, 6, 9. So it will be 3, see what is this? This series is nothing but 3, 6, 9, like that it goes on. Therefore, the common difference is equal to 3. Therefore, nth term is equal to a plus n minus 1 of d. That is equal to your 3n, because 3n minus. But you must know that this is n minus 1. See, there are 2 terms here, there are 3 terms. Therefore, you see that here it will be n minus 1 term. That means 3 into n minus 1, that is equal to 3n minus 1. So here for this n it will be 3n minus 1. See, 3n minus 1, 3n minus 3, 3n minus 3 into x to the power of n minus 1. If it is 4, 3. Here also, here if it is 3, it is if it is a third term, it is 1 less. If it is a fourth term, 1 less. So if it is the nth term, 1 term less. So here you see that it is the n minus 1 divided by, see this also it is, see, 7, 10, 13 like that. So your common difference is, it is 3. Your common difference is 3. And you find, what is it you find here now? So here also you see that this is, you get this 3n, 3 plus, what is the first term? First term is your 7. 7 plus 3 into n minus 1, that is 3n, 3n plus 4. So if it is nth term, it is 3n plus 4, but you must know that here if it is 3, if it is the fourth term, 3 terms are here. If it is fourth term, you have got 3 terms here. If it is a third term, you have got 2 terms here. Therefore, if it is a nth term, here you must put it as 3 into n minus 1 plus 4. That is 3n plus 1. So here you see that this is 3n plus 1. This is 7 into 10 into 13 into this. So this is how we write the nth term. So I'll repeat this, how this is done. First of all, know that this is a arithmetic series with 3, 6, 9 like that. So your first a is 3 and the common difference is 3, and that your arithmetic is nth term is a plus n minus 1t. So 3 plus n minus 1 of 3. Likewise, the denominator goes on like this, 7, 10, 13. So here again, the first term is 7. It is also an arithmetic series with common difference 3. So you see that this is 7, 10, 13. Common difference is 3. This one. Now, analyze how the series is written. If it is the second term, x to the power of 1. If it is the third term, it is x squared. So if it is nth term, it is x to the power of n minus 1. So you see that here there are, if it is the third term, if it is the third term, there are 2 numbers on top, 3 into 6. So 1 less than the number of terms. So here what happens is, n number, you are taking the nth term, so 1 less. Here again the denominator also n but 1 less. So what happens is that, so your nth term will be 3n minus 1. So if you want, this is 3n. If you want the nth term, it is a plus n minus 1t, that is 3n. You want the n here, but this is the, you have to put n minus 1 terms. Therefore, 3 into n minus 1, that is 3n minus 3. So your nth term will have 3, 6, 9, 12 up to 3n minus 3. And likewise, you see that 7, 10, 13, the nth term is a plus n minus 1t, that is 3n plus 4, but it must be 1 less. The number of terms must be, number of items must be 1 less. Therefore, 3 into n minus 1 plus 4. Therefore, this is 3n plus 1. So, I am writing it here. So, this is the way the nth term is written. Okay. Now, having written this nth term, what is our an plus 1? So, you see that our an plus 1, see what is our an plus 1? An plus 1 means, replace this by n plus 1. So, it will be nothing but 3, 6, 9. It goes on up to 3n minus 3. And in the place of this, you will put n plus 1. So, it is 3n plus 3 minus 3. So, 3 and 3 will go off, giving you 3n. And likewise, come to this. This is also 3 into n plus 1 plus 1. That is 3n plus 4. So, here it will be what? It will be your 7, 10, 13. It goes up to 3n plus 1 and 3n plus 4. And here, replace this by n plus 1. So, if you replace by n plus 1 minus 1, so this gives you n. So, Here I am writing this an. I have explained to you in detail how we are getting this. Then I finding this an plus 1. Now the job is very simple. Now here of course there is nothing in this problem. What you have to do is no, you find this an plus 1. What is your a? It is like an plus 1 by an. Therefore an plus 1 divided by an. What is the an plus 1 by this one? So 3, 6 dot 3n minus 3 into 3n divided by 7, 10 dot 3n plus 1, 3n plus 4 into x to the power of n minus 1 into n x to the power of n, 3n plus. Multiply. See, if you divide this by an, this denominator will go to the top. I will have it as, say an means this an, this will go to the top. So we will have it as 7, 10 dot 3n plus 1 divided by, it is 3, 6, 9 that into 3n minus 3 into 1 by x to the power of n minus 1. So x to the power of n minus 1. So you see that this will go to the top. Now on cancellation it is very easy to cancel here. So I will do the cancellation here. So you see that this will go. So this 3n minus 3 and this will go off, and this will go off, leaving you with what? N minus 1. So this will be equal to, it is 3n divided by 3n plus 4 into x. So this is what. Now take limit. Therefore, limit n tending to infinity of an plus 1 divided by an is equal to n tending to infinity of, you can take this 3n outside, no problem at all. So you see that 3n divided by 3n into, see if you want you can take this n outside. So n 3 plus 4 by n into x. So this n and this n will go off, giving you, so this is 3 divided by 3 into x, that is equal to x, since 1 by n is equal to 0 as n tends to infinity. So you see that you are getting this as x. Now, see, now this is our 1. 1 converges if x is less than 1. 1 diverges if x is greater than 1. This is 2. 3. The test fails if x is equal to 1. Now you see that in these two cases we are confident that if it is less than 1, it all depends on the value of x now. So if x is less than 1, this series will converge. If x is greater than 1, this series will diverge. But what will happen if x is equal to 1? That's why I told you, if it becomes an ambiguous case, whether it will diverge or converge, then we have to go for other tests. So let us apply. Now to find out, to find for x, let us apply Raabe's test. So let us apply now for Raabe's test. So I am going to apply Raabe's test for this. I will call this as my, see, I will call this as my 2. I will call this as my 2. Now let me rub off here. See, you see that? See, what is Raabe's test? Raabe's test is is this. If limit n tending to infinity of n into an by an plus minus 1 is equal to L. If L is greater than 1, the series converges. If L is less than 1, the series diverges. So we have to now find out what will happen if when x is equal to 1, what will happen. Now we apply this Raabe's test and find out whether it is convergent or divergent for the value x is equal to 1. Now what I do here is that, now what is my an plus 1? So what is my, see here, this is what you have here. This is your an plus 1 divided by a. This is your an plus 1 divided by this. This is what we have. Now an divided by an plus 1 is equal to, see, it is 3n plus 4 divided by 3n into 1 by x using 2. From 2, it is from 2. I have written, this is from 2, I have written here. See, 3n. See, you have to put it upside down. An plus 1 by an is this. Now, an by an plus 1 will be 3n plus 4 divided by 3n into 1 by x. Now, you have to take x is equal to 1. So, we have to find what will happen to the series if it is x is equal to 1. So, when x is equal to 1, an by an plus 1 is equal to 3n plus 4 divided by 3n. Now, see, now n into an by an plus 1 minus 1, limit n tending to infinity will be equal to limit n tending to infinity of n. See, what is your an by? This is 3n plus 4 divided by 3n minus 1. So, this will be equal to limit n tending to infinity of n into, so you see that this is nothing but, say 3n will go here, so 4 by 3n. So, see this n and n will go, so there is no need for a limit, so 4 by 3. This is equal to your LC. Now, L is equal to 4 by 3 is greater than 1, therefore 1 converges for x is equal to 1. Hence, 1 converges for x is less than 1 and greater is equal to 1. 1 diverges for x greater than 1. So this is how we apply the Raabe's test in order to conclude whether the given series is convergent or divergent when a particular x is equal to 1. So this is the way that you do this problem. I will teach you one more problem using what is called the integral method. So you see that here. See, by the way, I am using what is called the Cauchy integral test. See, what here it tells you is that f of x is monotonic decreasing function. It is called monotonic decreasing function. Monotonic decreasing function. Decrease. See, what happens is try to know that if you are giving if I am given a series, see, it is the first term, for the first term some value can be here, For the second term, some value can be there. For third term, some value can be here. So like that, you see that you may get, this is called a falling, it is called a monotonically decreasing sequence. So you can imagine the series as as good as points in a graph, so that the summation of the series is nothing but the integral of it. The summation of the series can be thought of as the integral from the initial point to the final point, infinity. We can take to be infinity. So you see that it will be going there. It is a monotonically decreasing sequence. Now we have to find out. Now instead of using now the algebraic methods, now what we do is we go for the integral, because we can think of, we can imagine the algebraic summation also as an integral summation if the points are taken very close, that if it is continuous. If the points are very continuous, you see that it is possible for us to go for integral summation. So you see that now we think or we imagine this algebraic summation as an integral summation and work out using the integral method, namely this Cauchy integral test, to find out whether the series, given series is, because I am going to plot it. If I plot it in the graph, it will be a decreasing sequence like this, and it is decreasing going like this. Now my job is to find out whether this is a convergent or a divergent series. So here what it tells is, if f of x be a positive monotonic decreasing integral, it must be an integrable function. You must be able to integrate and get you must be able to integrate the function. It is called an integrable function. So if f of x is a monotonic and decreasing function, and then such that f of n is equal to n, that is, this can be represented as an algebraic series. It can be expressed as an algebraic series. So if you can do that, f of n is equal to un are all positive. Here you see that they are all positive integers. They are all positive numbers, I should say. So every un is positive, and that it is line going like this, f of n integers, then this as a series converges if the improper integral, if this improper integral 1 to infinity f of x dx is convergent. That means I imagine I equalize this series, algebraic series, as an integral, as a function which can be integrated, and if it is integrated from 1 to infinity, if it is convergent, the improper integral is convergent. Otherwise, if it is convergent, that it has got a finite value. Convergent means it must be finite. If it is finite, then this is convergent. If this is convergent, this series is convergent. If it is not, so it is a divergent series. So this is what the Cauchy's integral test says. Now I will take a simple problem and tell you how that is applied. Now this is a problem where I am going to apply the Cauchy integral test. Now you see that here I write this. So try to understand that your algebraic series can be thought of as a graph drawn on a sheet, and that it is a monotonically decreasing. So instead of going for algebraic summation, I go for integral summation from 1 to infinity, so that what will happen to that integral value? If it is finite, it has got a convergent. If it doesn't exist, then you see that it is divergent, and hence this series, corresponding series, will not exist. Okay. Now that is, it's a divergent series. Okay. Now say I will take this. See what is given here now. You are given this. See, you are given see, s is equal to now here again you must know that in all the, I repeatedly tell in all my classes that you must be able to find out the nth term. What is your nth term? If you know the nth term, that nth term can be equivalently written as a function of x. So we can write. Now what is my that is un here? So your un is equal to, see it is 2, 3, 4, 5, it goes on like this. But 2 means what is that? 2 plus n minus 1. The common difference is 1. So it's the first number is 2, a plus n minus 1b. So you see that n minus 1 plus 2 means it will be equal to n plus 1. So this is your 1 divided by n plus 1. And likewise if you start with 3, so you have to put 3 here. But the common difference is again 1 only. So you put it as 1. So what will happen here? 3 plus n minus 1 by d means it is 1. So n plus 2. So this will be n plus 2. Now to find whether sigma of un 1 to infinity, that is sigma of 1 by n plus 1 into n plus 2, 1 to 10 infinity is convergent or divergent. Divergent using, I will write it here, using Cauchy integral test. Cauchy's integral test. Now let's see your f of x be equal to, it is x plus 1 into x plus 2. Now you see that when you start giving the values for this x, you see that this is 1 into 2. It is monotonically decreasing only. See, this is 6, this is 12, this is 20. So you see that every number is a decreasing one. That means it is a monotonically decreasing. And this is also integrable. This is also integral. Now we have to integrate, simple integration, and find out whether, and simple integration starts from what? 1 and it must end at infinity. Find out what is the value of it. If a finite value exists, this will be a convergent series. Otherwise, it will not be a convergent series. That's all. Okay. That is the divergent series. Now, integral of 1 to infinity f of x dx is equal to integral 1 to infinity 1 by x plus 1 into x plus 2 into dx. We know that, see, partial fractions we know that using partial fractions, let 1 by x plus 1 into x plus 2 is equal to a by x plus 1 plus b by x plus 2. Therefore, a into x plus 2 into b into x plus 1 is equal to 1. So this is 1. Now what is how will you get the values of this? Put x, if you want x is equal to minus 2. If you put x is equal to minus 2, this is 0. This is minus 1. So b into minus 1 is equal to 1. This implies b is equal to minus 1. Take x is equal to minus 1. So if you put x is equal to minus 1, this is 0. So this is plus 1. So a into 1 is equal to 1. So a is equal to 1. So you see that put x is equal to minus 2 means you will get the value of b. Put x is equal to minus 1, you will get the real value. So what is the value of a? A is 1 and b is minus 1. So you see that this is 1. This is your 1 and this is minus 1. And therefore you can write this. So I will put it here. Therefore your integral of 1 to infinity f of x dx is equal to 1 to infinity of 1 by x plus 1 dx minus 1 to infinity of dx by x plus 2, that is equal to 1 to infinity of d of x plus 1 divided by x plus 1 minus integral 1 to infinity of d of x plus 2 divided by. So you must know that this is d of x plus 1 means what? Again you are getting dx only. So this is of the form dx by x. By dx by x is log x. What is that? Dx by x is your log x. So this is nothing but what? This is your log of x plus 1, and this is, it is 1 to infinity minus, it is log of, you can write this as, you can write this as, it is, okay, you can put it in any way, that is, it is log of x plus 1, it is 1 to infinity minus log of x plus 2, 1 to infinity. You can write this, actually I will write it in a different way. So this is equal to, say it is log of x plus 1 minus log of x plus 2, 1 to infinity. This can be written as log of x plus 1 divided by log of x plus 2, because a by b form, and it is 1 to infinity, that is log of 1 plus 1 by x plus 1 plus 2 by x. You will get this as yes. So this is from 1 to infinity. Now you see that this is log of, it is, see this infinity, if you put 1 by x, infinity means 0. So 1 by 1 is log of 1 minus log of, if you put 1, it is 1 plus 1 is 2, and it is 2 by 3. So you put infinity, this is 0, so log, this is also 0, log 1 minus, you put x is equal to 1, this is 2, and this will be 3, so you get this to be equal. So this is nothing but 0 minus log of 2 by 3, or this is nothing but what? You can write this, if you want I can write this, minus of log of 2 minus log of 3, that is equal to log of 3 minus log of 2, that is equal to log of. So what is that we get here? So it's very simple actually. See, I have taught you how to go for these partial fractions. So using method of partial fractions, I do this and I write it in the form dx by x, so that the integration of this is log x. So this is log of x plus 1, this is log of x plus 2. Both are from 1 to infinity, therefore log of x plus 1 minus log of x plus 2, 1 to infinity. But this is log a minus log b, that is log of a by b, 1 to infinity. What I do is I take this x outside, so it will be 1 by x, 2 by x, and x will get cancelled. Now you apply infinity. When you apply 1 by infinity is 0. Actually 1 by infinity is 0. 1 by infinity is 0. So you see that this is log 1 minus, if you put 1 here, 1 plus 1 is 2, 2 plus 1 is 3. So log 1 is 0 minus log of 2 by 3, that is minus, this is log of a by b, log 2 minus log 3. Take this minus sign inside, so this log 3 minus log 2, that is equal to log of 3 by 2, and this is finite. Log of 3 by 2, it has got a value finite, and therefore the integral exists. So the integral exists means what it is, it has got a finite value. Since, now say it right here, since since by so this is all about the problem, and I'll be continuing with the convergence divergence for another 5 or 6 classes to do some of the difficult problems and also problems which are most commonly asked in university examination, either in engineering or arts colleges. So I'll be doing, and I definitely will help the students. Do not fail to subscribe to my channel so that you will definitely gain by watching my videos. Keep watching my videos. Thank you.